enterprise is it ready for yours? Can it integrate into your place of business? There is, in the last 9 months to 12 months, the last year or so, there's been a lot of movement in the third-party client software piece. Tivoli, TNG, Legato, they all have Linux agents now. Unfortunately, in a lot of cases, you find yourself that they support Red Hat 6.2, they don't have Red Hat 7.2 support, or they still support Red Hat 6.0. You know, so it's kind of a battle to always deal with the third-party vendors.
Can you repeat that, please?
What's that?
Can you repeat what you just said?
Well, one of the things you run into with third-party software is that some of them will support Red Hat 7.2, and some of them won't. Some of them are still, supporting Red Hat 6.2 or 6.0, and are having a problem, getting their products up to speed for the newer releases that have come out. One thing that we all know is that Linux moves at a very rapid pace. There's a new version of Linux coming out almost every 6 months, and there's more kernels coming out all the time. And so, it's a big task to stay on top of the distribution and stay current with patches and all the new hardware support and stuff. But like I said, the third-party piece is coming along. Most of the big enterprise players, thanks mostly in part to IBM and all the money they put into it, they've jumped on the bandwagon for Linux and have now made their clients available. So they'll find products like Tivoli, TNG, and what are some other monitoring stuff? So let's go ahead and move on. BNC, yep, that's another good one. Even the BNC Control N stuff. Is that what you're saying? You said Control, but the Control N, they have a client for Control N too. So BNC is a big player in the enterprise.
I think that's going to, in the future, that's going to grow much faster than it has because of IBM, because of HP Compact. Some of the big players in the Unix marketplace are starting to look at Linux as being a major operating system within their offerings on their platforms.
And there's going to be a learning curve, required too for these third-party companies, because they're going to have to learn how to deal with Red Hat changing glibc every 9 months. They're going to have to learn how to deal with that kind of stuff and make sure that their release cycle kind of lines up with Linux, because in your enterprise, your customers are going to want the features that Linux provides, especially when the next kernel comes out, 2.5, 2.6, whenever the scaling is going to support 32 or 64 CPUs. Whenever that next big performance gain comes in, your customer's going to want it, but you're not going to be able to offer it because you have to wait for all the disk features like that. All right, so monitoring, big piece. That's the box has a problem. The alarm goes through your network, pops up on somebody's screen, they know who to page, get on the phone, make a call, you resolve the problem. That's that whole process. Okay, moving on. Backups, another important topic. You need to be able to provide all backups to your environment. The enterprise shop already has a process in place for backups. They're not going to come up with some new custom design thing to support your first 100 Linux boxes. If you're going to replace everything with Linux, then maybe you want to consider something new. But for the most part, you've got to be able to integrate. So you've got to, again, rely on the third-party vendors to produce clients that run with your Linux boxes. And again, a lot of that is now with a lot of good momentum. I really haven't found any of the major backup players that don't have a client for Linux yet. And then the last question, of course, is the off-site storage management. Any place has some process for taking the tapes off-site, storing them somewhere safe. Right, next one. Capacity planning. That's always an important part of any enterprise, because when you consider an enterprise, you're usually talking about a lot of systems. Anytime you have a lot of systems, a life cycle is a particular part. You can't just roll out 1,000 systems in a month, and then a year or 2 years later, when the systems are old, you don't replace all 1,000 systems at once. You've got this whole process running all the time. You're always purchasing equipment, you're always getting rid of the old stuff, and you've got to be able to manage all that. And part of that is making sure that when you purchase equipment, you buy the right equipment for the right project. You don't want to buy equipment that just sits idle. If you do that, you're wasting money. So part of that is this capacity planning category. Comment there is that you can't just throw darts and pick what kind of hardware you want. Purchasing hardware size poor and cost prohibitive. You You need the tools to accurately measure whether a box is performing well or not. SAR is a standard Unix tool. It's a system accounting and reporting. It's become part of the standard Red Hat distribution. Basically, it's a little cron job that runs every 5 minutes, does a quick status box, saves things in the database. So you can see the system, at 3 o'clock, the system was this busy, there were this many I/O requests, this much swap available. It's a good general feeling for how busy the box is. But it's not very granular. It's not going to tell you what's consuming the swap. It's not going to tell you what process is taking up the most part of the system. There's a lot of things that SAR can't offer you. And later on, when I get down to my final topic, which is root cause analysis, SAR isn't going to provide you with the clues that you need to find out what caused your box to crash. So again, you're depending upon either some open source project or an enterprise who want to use the same tools you use everywhere else, depending upon your third-party vendors. Another comment there is the old historical baseline. Companies that are starting to deploy Linux don't have a long history of dealing with PCs and Intel processors and the 2 gigahertz processors. How much real power is that when you're trying to run Oracle? The 2 gigahertz processor running Oracle from Intel is a lot different than an 800 megahertz processor from Sun. The characteristics are different. One has more cache, one has less cache. One has a bigger memory bus, and the other one doesn't. There's a lot of pieces involved. And your capacity planners have to understand this and know that when they're speccing out a particular box, whether they're giving you the right thing or not. And that usually comes about through some type of history. Guy knows that the last 100 boxes he rolled out with Linux on, this worked well. So, it's that history, and you don't have that right now in most places. But again, it's coming along nicely. And then, of course, the people who understand the baseline make up accuracy. And that boils down to retention and training again. To be able to keep those people, you also need to train your new people so that they learn how to do all this. All right, next. Storage management. This is a big topic in any enterprise. Typically, you don't deploy 1,000 systems with a bunch of internal IDE disks. You either have some type of large-scale storage locally attached, which we're talking about like a network appliance or locally attached SCSI storage with RAID hardware integrated into it, or on the larger scale, if you're talking about that SAN again. You've got 1,000 systems that are all attached to the SAN, but you do need the means to manage all that storage. You're not going to do it by managing it disk by disk. So that's where a company like EMC makes all their cache, because they provide you large-scale storage solutions, and they also give you the software to help you manage it. If a disk fails, it's almost oblivious to a PC over here. If the disk fails in the SAN, a little blip shows up on a completely different screen that goes to a different group, where some guy's got a box of disks, or he dispatches some vendor to come in and replace the disk, and all they do is they throw the disk with a blinking light, pop it out, pop a new one, and they go home for them. So that's true storage management on the large scale. But not everybody can afford that. So in the case of Linux, you've got products like the RAID tools, which we're going to talk about tonight, and also a new developing logical volume manager. And the whole logical volume management piece is basically to take, what was your definition for it?
It abstracts the physical disk. It gives you a logical volume layer between your file system and the physical partitions. So you lump the physical partitions into a big pool, and then the file systems talk to the logical volume manager to then extend or shrink or...
To give you kind of the novice approach, think of yourself as a home user who's got a box full of 2 gig drives. Well, if you can take all those 2 gig drives and plug them into a system, or consider them to be SCSI drives because it's easier to see if you can plug them all into the system. But you get all these 2 gig drives with logical volume managements. You can bind them all together and make them look like 100 gig drive to your system. That's the concept behind logical volume, because you abstract the whole what this pool of disks are, and you either combine them or divide them, or combine them all and then subdivide them so that the system gets what it needs. So that's the logical volume management piece. Another piece of storage management is the journal file systems. This is a big thing for enterprises. Journal file system, in a nutshell, is, it's hard to describe in a nutshell, I shouldn't have said that. The the concept behind the journal file system. Well, let's talk about a regular file system. Everybody knows if you unplug your PC, plug it back in, your disks have to run the FSCK, the system comes back up, just like a Windows box where it has to run check disk. And that runs through your system and says, oh, you've got all these files here, I don't know what to do with them. I'll either dump them in, Unix terms, I'll dump them in the lost and found file, or I'll be able to repair your disk, or in the Windows sense, it creates all those check disk files, or files 000 through, 1,000. And of course, those are all your DLL libraries, so Windows doesn't boot anymore. But what the whole point behind the journal file system is to improve the speed of your FSCK. And the way it does that is a journal file system maintains a journal. It's basically a little table of the most recent I/O interactions with your disk. So if the disk does fail, all the FSCK has to do is look at the journal and say, oh, only these parts of the disk have recently been modified. I don't have to go scan the whole disk looking for these possible errors. I just have to go look at these little pieces here. So a journal file system will usually be able to check itself in a couple of seconds, whereas an FSCK on a multi-terabyte file system attached to your SAN could take hours or days. So that's an important piece for an enterprise, especially if you're talking about your SLA. Systems crash, it happens. But if you're going to waste your whole SLA time for the system to do an FSCK, that's a clear and present danger. You want to be able to have journal file systems. Big piece. Number of journal file systems have cropped up recently. ext3 is a journal file system. RiserFS is a journal file system. IBM has its. XFS. And then Silicon Graphics is released here. Silicon Graphics. XFS. So even the main players in the Unix world have ported their JFSs over to Linux. Red Hat's still standing true behind ext3. The nice thing about ext3 is it's backwards compatible with ext2. So if you have a problem with the journaling, you just go into your etcfs tab and say it's no longer ext3, it's just ext2. System reboots, now you have a traditional ext2 file system. So that backwards compatibility kind of gives you a nice warm fuzzy feeling, but you really want the journaling. You shouldn't have to turn it off.
One of the things that you need to mention is that these journal file systems are slower than the non-journaling file systems. And you have to look at which speed of each one that they have been benchmarked. JFS from IBM, I believe, is one of the better ones. The speed. But I don't really recall the statistics.
From what I recall, RiserFS accelerates at file systems that have thousands of teeny tiny files because it's an algorithm based on a binary tree. ext3 is backwards compatible, file system structure is the same. It's pretty much just ext2 with German, but even then the performance isn't bad. And what you gain by it is definitely a big win. So only in cases where your disk I/O is, a severe penalty for your application, in those situations you need to consider whether or not you want to turn on German or not. So, good point. All right, and again, the last point, we're not remodeling to integrate Linux, so again, we've got to be able to fit in with the existing area. One other comment, hierarchical storage management systems. This is, the fancy of a lot of enterprise shops because they usually equate, pennies per megabyte, and tapes always come in cheaper than hard disks. So if you've got a system that can basically say, that this data has been accessed in the past 10 years, why does it have to sit on the disk? It can migrate its way to tape, and then when the request comes in that somebody wants to use that disk, find its way back here. There's actually a completely automated system for this, and that's what this HSM environment is. And there's a number of different vendors trying to produce things. I think HP has a big one, but yes.
Journaling file systems, they only help you recover faster, they don't help you recover more data better?
No. My understanding from journal file systems is that they still have the same problems as regular file systems. They just do it a lot faster.
I think it depends on the particular journal file system, actually. Some of them use the journal for not only write down what the blocks are changing, but the actual data that changed in the journal is just a sequential list. And that way, since accessing it sequentially is very fast, you can write out the journal entry very quickly, whereas when you go to update the actual file of this, you have to seek all over the place. So there's a very good chance that the data will got into the journal before it actually got into